Let's talk today about acids. So yesterday we talked a little bit about ionic compounds. There's binary ionic compounds, and then there are ternary ionic compounds. And acids is actually somewhat similar to that. You can see with acids here that we have what are called binary acids. And again, acids are a big part of the AP program. And so it's just a good idea to start out here at the beginning, kind of learning how to name them and how to write their formulas. So we are going to talk about them later, but just for the purpose of learning how to name them and how to write their formulas, a very basic definition of an acid is something that produces hydrogen ions when it's dissolved in water. And so the formula of the acid that we use is something that has to start with an H. Now that isn't entirely true. Some acids that we will learn about later this year won't necessarily start with an H, but for now, that's a good way to recognize an acid other than obviously H2O. H2O is not an acid, but in general, if something begins with an H, we can assume that is an acid. So the first type of acid that we need to be familiar with is what is called a binary acid. And binary means two, like we use a binary code with our computer system. The computers that we use all use just a bunch of ones and zeros. There's two different digits that computers use. So a binary acid is just that. Bi means two, so it is just an acid that contains two elements. Obviously, one of them has to be hydrogen. The other one can be any other non-metal, obviously other than the noble gases. So a binary acid is formed when hydrogen ions combine with monoatomic anions. So again, monoatomic, mono means one, and atomic means atom. So it's a one atom anion. So for example, Cl minus is a monoatomic. It's a one atom anion. It's got to be a negatively charged ion. So S2 minus is a monoatomic anion. N3 minus is a monoatomic anion. Okay, what's not a monoatomic anion is something like sulfate, SO4 2 minus. See how that's made up of multiple atoms? Okay, that is not a monoatomic. That's a polyatomic ion there. Okay, so to name a binary acid, we do use the prefix hydro. So for every single binary acid, we're going to use the prefix hydro at the very beginning. And what that does is that distinguishes the acid between a binary acid and an oxyacid. Oxyacids do not use the prefix hydro at the beginning. Okay? So when we deal with these acids, for example, HCl, again, we use the prefix hydro, so this is called hydro, followed by the other non-metal name, well, the other non-metal is chlorine, with the ending changed to IC. So chloric, and then you put acid at the end. So that is hydrochloric acid. Okay? Now, with another acid, and again, anytime, notice that there's no oxygen in there. Notice when we get to oxyacids, we're going to be talking about acids that do have oxygen in them. All of the binary acids do not have oxygen in them. Okay, so let's look at another one here. Let's look at, for example, HI. Okay, again, you see that hydrogen at the beginning, you think, oh, that's an acid. So we know that it's a binary acid because there's only two elements. So I know that it has to start with hydro, and then that's iodine, so it becomes hydroiodic acid. Okay, so hydro at the beginning, the ending changed to IC, and then you write the word acid at the end. Okay, now one of the things you'll notice here, let's change it here just a little bit. Let's change it to H2S, and we'll talk about that too here in just a minute. But kind of similar to water here, except water, again, is not an acid. That with H2S, same thing, we've got hydrosulfuric sulfuric acid. So, same thing as before. That 2 really has no bearing on the name at all. Hydro, the sulfur, we put the IC at the end, and then we write acid. Okay, and then one more, and then we'll talk about why that 2 is there and why this 3 is here. Okay, H3N is called hydro, like always. Nitric, that's nitrogen. And then acid. Okay, so if it starts with hydrogen and there's only one more element with it, that is a binary acid. You must put hydro in the front. You always change the N to IC, and then you write acid. Okay, now before we talk about oxyacid, let's go back to, even right here, the H3N and the H2S, and we can even put HBr. Okay, notice that each one of those acids has a different number of hydrogen atoms attached to it. And it's kind of like an ionic compound, that when you deal with an ionic compound, you have to cancel out the charges. Well, with acids, it's the same thing. Bromine, we know that bromine has a charge of -1. Okay, well, hydrogen always has a charge of +1 when it's with another nonmetal. So therefore, there needs to be one hydrogen to cancel out the one bromine. So overall, that results in an overall charge of 0. Okay, but sulfur, on the other hand, sulfur does have a charge of -2. But again, because hydrogen has a charge of +1, there has to be 2 hydrogens there. And so there, all total, that 2H, the 2 hydrogen atoms gives us a +2 charge. So again, overall, we get to a charge of 0. Okay, and then as we kind of follow the pattern there, nitrogen has a -3 charge, so there has to be 3 hydrogens. Just like an ionic compound, anytime you write the formula for a binary acid, you must even out the charges. Whatever the charge is on the anion, that's how many hydrogens go in the acid formula. So, for example, if we write hydrofluoric acid, we go, okay, it has hydro. That means it has to be a binary acid. If it's a binary acid, we know that it's just hydrogen and fluorine. So fluorine has the symbol of F, and it is a -1 charge. So therefore, the formula is just HF. Okay, so anytime you're given a formula, or excuse me, a name, and they want you to write the formula, if there's a hydro in the front of it, you know right away, that's your giveaway right there, that must be a binary acid. Because again, the oxyacids do not have the hydro in the front. Okay, so let's go ahead and jump down now to oxyacids. So as you can see here, an oxyacid is one when hydrogen ions combine with polyatomic oxyanions. So again, let's talk about what that means. Poly means many, atomic means atoms. So you've got many atoms, and you've got an anion, a negatively charged ion, just like up here, but that has oxygen in it. So again, some examples of polyatomic oxyanions are sulfate, SO42-. That is a polyatomic, because there's more than one atom, oxy, because it's oxygen, anion. Okay, nitrate is another one, NO3-. And I think if we come back up here, oh my goodness, what are here we go, right here. Okay, those are the polyatomic ions that you might and certainly could see on the AP exam. Okay, so any of these up here, and notice that again, all the negatively charged ones all have an oxygen in them. Obviously, here's ammonium with its positive charge. But again, we're looking for, what did it say again? With polyatomic oxyanions. So they have to be anions, they have to be negatively charged, which they all are, and they all have oxygen in them. So every single one of these in here, other than ammonium obviously, is a polyatomic oxyanion. Now, how does that change? Okay, this gives us a combination of hydrogen, oxygen, and sometimes a metal, sometimes another non-metal. For example, here on permanganate, that's a metal. In general, it's one or more non-metals, like phosphorus, chlorine, sulfur, etc. Now, to use an oxyacid, you use the name of the oxyanion and you replace the ITE with OUS or the ATE with IC. Let me talk about what that means, okay, here in just a second. Okay. Now, these polyatomic ions that you need to know, I believe there are 12 of them all total. Those are 12 that, again, they help you with ionic compounds. They're also going to help you with acids as well. Okay, and what I meant by 8, the whole ITE becomes OUS, the ATE becomes IC. For example, if you have H2SO4, like sulfate up there, so that is sulfate. So if it ends in ATE, sulfate, it becomes IC. So that becomes just sulfuric acid. Notice there is no hydro in the front. If you put hydro in the front, then you're back to being a binary acid. Okay, these are not binary acids. These are oxyacids. Oxyacids, you do not put hydro in the front of. Okay, another one, HC2H3O2. Is this right here is acetate, and so acetate becomes acetic acid. And again, notice here when we did the formula, here there's 2 hydrogens, here I only put 1 hydrogen. Okay, and again, what does that come back to? Comes back to the charges. Sulfate has a -2 charge, that's why there's 2 hydrogens. Okay, acetate on the other hand, if we come back up to here, acetate right here only has a charge of -1. So since acetate's a -1 charge, we only need the 1 hydrogen. Okay, now what about this one over here where the ITE? Okay, what if you had, for example, HNO2? That was on the exam just a couple of years ago. You didn't necessarily need to know the name of it, but you did have to use the formula for a problem. Okay. Well, that looks just like HNO3, and you should know the name of HNO3. That's nitrate, and nitrate, therefore, is going to become nitric acid. So, well, what about this formula here? This formula here looks just like nitric acid, but it has 1 less oxygen, which means that this NO2 is called nitrite. And nitrite, now we're back to this part right here. If it ends in ITE, it becomes OUS at the end. And so this is nitrous acid. So really, most of these up here can be written another way with 1 less oxygen. So for example, sulfate could also become sulfite. What's the formula for sulfite? Same thing, same charge, same everything, just 1 less oxygen. Instead of chlorate, and again, I'm just kind of choosing the more common ones. Sulfate does it pretty commonly. Nitrate does it. Chlorate does it as well. If you take 1 oxygen away from chlorate, it becomes chlorite. And chlorite is ClO2 minus. Okay, just like chlorate, but just with 1 less oxygen. Okay, and really those are kind of the 3 common ones. I mean, could you have carbonous acid from carbonite? Technically you could, but in general, if you're going to see an ITE one, it's usually one of these 3. I guess you could have phosphorus. We could throw that one in there as well. You could have PO3, 3 minus, which would make that phosphite, and phosphite would become phosphorus acid. Okay? Now, on the AP exam, you will have to deal sometimes with acids, quite commonly. Now, I will tell you, well, what if it's not one of these acids? Like, for example, what if they talk about propanoic acid. And you're like, huh? Propanoic acid? Never heard of that. Well, then they know that. They know the acids that you should know and the acids that you don't know. So if they know that you're not going to be familiar with that acid, then they're going to give you the formula. Okay, so they might start a problem by saying, a 25 milliliter sample of propanoic acid, and then afterwards, after they give you the name, they'll just give you the formula. They'll say C3H7O2, I believe is what it is. Okay, and then they're telling you, oh, look, here's the formula of propanoic acid. So if they give you an acid that you're not familiar with, don't be scared about that, because they will give you the formula. And many times, honestly, you don't even need to know the formula, but a lot of times they'll give it to you anyway. So again, just a quick review here with acids. There's two different types. There's binary and oxy. Binary always start with hydro and always end in IC. And again, it's just hydrogen with one other element, not oxygen. Okay? And then you have your oxyacids, where you can have two different scenarios. You can have the acid that ends in ATE, and you can have it where it ends in ITE. And remember, ate becomes ick, and ite becomes us. And again, in order to do that correctly, you have to have these 12 polyatomic ions here memorized. And once you do, then when I say perchloric acid, you go, oh, perchloric acid. Oh, yep. No hydro in the front. If there's no hydro in the front, it has to be an oxyacid. And if it's an oxyacid, perchloric means it came from perchlorate. Perchloric, ick comes from 8. So ClO4 minus becomes HClO4. Okay, and really, guys, there's not a lot. I mean, other than these 12, you should know those acids. And really, this isn't going to form an acid here. Bicarbonate isn't going to form it. If it's going to form the acid, it's going to form it with carbonate. Hydroxide, let's talk about that for just a second. If you take H, if you add an H to that, you make HOH, which more commonly is written as H2O. Peroxide, if you put a hydrogen with that, obviously, so this is not an acid. If you put hydrogen with that, it becomes H2O2, which is the name of hydrogen peroxide. So that also doesn't form an acid. So really, we're down to 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of those 12 that you should know that you can form an acid with. And then obviously there's the ite version of them as well. Chlorite, sulfite, nitrite, phosphite, things like that. Okay. So you should have a homework packet. You should have some questions dealing with acids. Go ahead and get to those now and get to work on them.